All right, so we're starting chapter 9 today. We're skipping 8.5. We've skipped two sections now, one out of chapter 7 and one out of chapter 8. And we're pretty well back on track here. So I'm working on, this lecture shouldn't be very long. Then we're going to have an online class together on Thursday. We're going to be back together and we're going to finish chapter 9 probably. And then we'll move on here to, it's not going to be long. This semester is going to be over with. So hope you're doing well and staying safe. I know it's not the greatest circumstances here. I don't like it either. I'd much rather be in the classroom with you folks, see your smiley faces, and I enjoy that. That's really what I enjoy and love to do is be in the classroom with all you folks. That's kind of what I signed up for, but this is just a necessary evil, if you want to say, these videos. And so hang tight, hang in there. You're doing well. Let's move ahead here. So I'm on page here 494. Change my pen color here. Number 6. I think you'll catch on pretty quick. So I sure hope you're caught up with hypothesis testing and how it works, because it's really important that you understand the steps to hypothesis testing, because it's used pretty much the rest of the term. Okay, this whole next test is one big hypothesis testing. Okay, number 6. Teacher salaries, New York and Massachusetts lead the list of average teacher salaries. The New York average is $76,409, while the Massachusetts makes an average annual salary of $73,192. Random samples of 45 teachers from each state yield the following. So we're going to compare two states. There's the data in the problem. You can see it. And then it says at alpha equals 0.10, is there a difference in the mean salary? So here we go. Before we had a single mean, now we got two of them, Massachusetts and New York. Is there a difference? So does the means equal each other or not equal each other? Difference means not equal. Is there a difference? Are they different? They're not equal to each other. So look how I set up the hypotheses. Okay, equals, not equals. That's all we need to be able to do there. We got the data. So now you need to know that Massachusetts is the first one and New York is the second one. So you got to make sure that's straight in your mind when you enter the data. Massachusetts is 1, New York is number 2. Okay, here we go. Go get your calculators out. Alpha's 0.10. So we're going to go to stat tests. Now we're going to go stat test number 3. And we want stats. So highlight stats. Okay, highlight stats. And they want standard deviation for the first one. Standard deviation for Massachusetts is 8,200. Standard deviation for the second one is 7,800. The mean for the first one is 73,195. The second one is 76,409. Make sure you get them in the right spot. They want N1 there. That's going to be, is it 45? And then the second mean is 76,409, and another 45 we want not equal to. Okay, so look at the little screen. Look carefully. There you go. Look carefully in my data how I entered it in. Okay, I'm getting ready to calculate. There it all is. Scroll up a little bit. Look at the top of it. Under stats, I got them right, all in the right order. Hopefully the right numbers: 73,192, 76,409, 4545, 80. Oops, you know what? I made a mistake. It should be 7,800. I had 780. So I've corrected that up on top there. I got 7,800. So I changed it. Now we go to calculate. And I got a p-value. We're going to go with just p-value in this chapter, 0.0567. Now, when I graded the quiz, some people they didn't quite get the p-value very carefully, okay? This p-value is smaller than alpha, which is 0.10. That means reject H0. I need to see that on every problem. Reject H0 or accept H0. I want you to write that down physically. Write that down. If p-value is small, less than alpha, it's small, tiny, no good, reject it. Reject what? The null. We're talking about the null in every problem. So here we go. So rejecting the null means rejecting the first thing. So that means we accept the second one. So there is a difference. So there is a difference in teacher salaries in Massachusetts and New York. All right. Let's do another one. How about number, oh, let's see here. I guess it doesn't really matter. Let's see. How about number 8? At age 9, the average weight of the average height for both boys and girls is exactly the same. A random sample of 9-year-old yields these results. At alpha equals 0.05, do the data support the given claim that there is a difference in heights? Is there a difference in heights? Same scenario, not equal to and equal to. Alpha is 0.05. So we got boys for the first one, and we'll say the girls are the second one, okay? There's the data in the book. Let's go ahead and enter it in. See how quick this is going to be. Stat test number 3. Get the right standard deviations in. 7.2 for the first one, 9.1 for the second one. The mean for the first one is 28.5 with a 40 size. Second one is 35.2 with a 40 size, not equal to. Calculate. I got a p-value here of 2.6 times e to the minus 4. Pay attention. So we're going to add 3 zeros in there. That's really small. So we're going to really reject H0. There is a difference between heights of boys and girls. There is a difference in heights of boys and girls. Is it at a certain age? At 9 years old. So you should be able to just cruise through this section. Let's see. What else should I do here? Let's, I guess, try number 12. ACT scores, a random sample of 1,000 students nationwide showed the mean ACT score of 21.4. Random sample of 1,000 had a mean of 21.4. Ohio was not used. A survey of 500 students selected Ohio scores showed a mean of 20.8. Okay, so this will be, we'll call this US, we'll call this Ohio, okay? If the population standard deviation is 3, can we conclude that Ohio is below the national average? So it looks like we're going to use a standard deviation of 3 for both of them, would be my guess. That's all we have given there. Alpha's 0.05. Okay, now I'm looking for a good hypotheses on all these problems. Some people are getting sloppy and I don't quite understand what you're writing. You got to have the mean in there every time. The last chapter, it was the mean equals something or the mean was less than something. They want to know here if the can we conclude that Ohio is below the national average? Okay, so Ohio is the second one, right? So if Ohio is below, then the first one, we'll call it the first one, will be greater than the second one. What do you think about that? So US is a 1, Ohio is a 2. So if Ohio is lower, then 1 would be greater than that, bigger than that. All right, let's go run the data now. Stat tests, number 3. Standard deviation, I'm going to put 3 on both of them. First one is 21.4 with 1,000. Second one's 20.8 with 500. And then we're going to use a greater than symbol. Should look like this. Take a good look. Look at my little screen. I got it all written in there. Calculate. So I've got a p-value 1.3 e minus 4. So we know it's going to be small. Less than alpha, reject H0. Rejecting H0 means accepting this one. So the US average is higher than Ohio. So US average is better than Ohio. Okay. All right. So you can work problems from this section. Page 494. So no confidence intervals. They're going to ask you about confidence intervals. Some problems, skip it. Just do the ones that are hypothesis testing. So 5 through whatever you think here, 15 maybe. I think you should be able to, if you did well in the last chapter, you should be able to just roll this one right down. No problems. Okay, well, the next section is going to be a T. It's going to be a T. So in your calculator, it's going to be stat tests number 4. And when it says pooled, the answer is no. You'll see it when you go through look at the bottom of the screen there. See it says pooled? Make sure you have no on there. Everything else is the same. 2 data sets, same scenario for a T, unknown population standard deviation. Yeah, shouldn't really take nothing to do with this section. You got the data option, the stats option. I want you to start it. I think you can start on your own here, and then we can wrap up, tie up some loose ends on Thursday, and then finish up the chapter 9.3 as well. We're going to do both of that on Thursday. 9.3 is a bit more trickier, so I want to be with you guys and show you how that one works. But start 9.2, a T, on your own. Okay, I want you to work 4 problems. I bet you can do it. Okay, 4 problems. I've given you a good start there. Okay, we'll see you Thursday. Get these lessons done, stay caught up, and we're gonna ready to roll out the rest of this semester here. Really, we've got just a couple classes left. We actually got a catch-up day. We're in good shape. Stay on track. Okay. All right, we'll see you Thursday.